Hello, welcome to a video on section 3.3. This one will be actually on 3.3 extended, and the title of this section is called Linear Programming. Now, it does sound kind of like a weird topic, but you think about what linear means, that deals with lines. When you hear the word programming, you might think of like programming, like with like languages, like if you're trying to make a app on your phone or something like that. So it can sound kind of easy, but sound kind of complicated with the title here. What we're going to do is we're going to look at a particular word problem. And what I suggest that you do is get your textbook open. I know we haven't used the textbook much, but we're going to start using it more often now. Go to page 174 in the textbook and read that problem. Actually, I'll even read it out loud. They say a potter wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay. So a bowl, 5 pounds of clay. A plate, 4 pounds of clay. You want at least 4 bowls. You have 40 pounds of clay available. So again, in this word problem, because I do realize that some of you might be watching this video at school and may not have a textbook at your disposal, you're going to make bowls and plates. Bowl requires 5 pounds of clay. Plate requires 4 pounds of clay. You want at least 4 bowls. You have 40 pounds of clay available. And the profit, because we're going to try to make some money here, we're going to sell this stuff. The profit is $35 per bowl and $30 per plate. So here is the question. We have all this information, right? But here's the main question. How many bowls and plates must be made to maximize your profit? And a lot of these linear programming problems, the intent is to make money or maximize the amount of product you can get. So in a business, you want to make money or reduce your cost. So you're going to see problems that deal with like what's the minimum cost or what do you have to do to get the maximum profit, stuff like that. And if you do have the textbook with you, you can actually look at this problem and try to read it first and then watch my explanation, and hopefully this will make sense. Well, this does seem like a pretty tricky question. Like, you know, you could try guess and check. Maybe you can say, okay, I'll make like 6 bowls and maybe 2 plates and try to work out the numbers. But if you really want a precise way to get the answer and be confident that you have the right combination of bowls and plates to get the maximum profit. So here's what we're going to do. Here are the steps we're going to take to solve this problem. Actually, let's try a different color here. Step 1. Like any word problem, assign your variables. Step 2. This is going to be a little tricky, but you're going to write an objective function. I'll talk about what that means in a little bit. Step 3. You're going to write your constraints. That also seems a bit complicated, but I'll explain what that means in a short while. Step 4. Graph the feasible region. Again, this does seem a bit complicated. We'll explain that as well. Step 5. Locate the vertices. That'll be the corners of your feasible region. And then step 6. Test for profit. Oh, actually, 5 minutes. Test your vertices to see which one gives an optimum value. Okay, so if we look at step 1, what I'm going to do is I'm going to let x equal the number of bowls. Actually, that's what they do in the book. And y equal the number of plates. Now, if you think about objective, what does the word objective mean? It means a goal. There's a certain goal you want. We want to make money. So P is going to stand for profit. I'm going to introduce a new variable here. P is going to stand for profit. And because you make $30 for each bowl, and $35 for each bowl, and $30 for each plate, the profit will be 35x plus 30y. We'll come back to that later. Step 3, your constraints. Constraint means what you're limited by. Clearly, we don't have all the clay in the world to use. And clearly, we have to make at least 4 bowls. So that means that x has to be greater than or equal to 4, and x plus y has to be under 40. Actually, I take that back. 5x plus 4y has to be under 40. The reason why is because you're using 5 pounds of clay for each bowl and 4 pounds of clay for each plate. And because you only have 40 pounds of clay available, if you think about it, 5x is all the pounds used for the bowls, 4x is all the clay used for the plates, so it has to be under 40. And also, we're not going to have a negative number of bowls or plates, so we can say x is greater than equals 0, and y is greater than equal to 0. So step 4, you have to graph the feasible region. Feasible means what is possible. That's what feasible means. What's possible. So you're going to graph all these things here. So I'm going to make a whole bunch of tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I graph the first inequality, I'm going to have a vertical line, and I'm going to have to shade to the right. If I graph the next one, looks like the x-intercept is 8, and the y-intercept is 10 for this one here. And remember, x-intercept was when y equals 0. Y-intercept was when x equals 0. Actually, that's the other way around. 8 and 10. And we're going to shade below that line. And of course, this is x greater than or equal to 0, y greater than or equal to 0. So it seems like the shaded region will probably be somewhere in here. So any point in that shaded region will satisfy all those inequalities all at the same time. That's why we're doing this with graphing of linear systems of inequalities, because you want to see a practical application for this. Here are my corners. Well, the corners are easy. That's 4, 0. That's 8, 0. And I believe this will be 4, 5. The corners will always represent either the maximum or minimum value, because that's what we want here. We want optimum value. We want to optimize our profit. So step 5 has actually already been done. 4, 5, 4, 0, and 8, 0. So for step 6, we simply need to test each of those points. And we test it back into the profit function to see which one gives us the highest profit. So we get 140 plus 150. So if I made 4 bowls and 5 plates, and that would keep me within all the constraints, I make $290. Okay, that's not bad. That's actually good money. If I make 4 bowls and no plates, well, that's kind of a waste because we're wasting a lot of clay there. It's $140. So I don't like it. If I make 8 bowls and no plates, so at least I'm making 4 bowls and I'm using all the clay that's out there, that should be $280, I believe. Yeah. So it's good money too, but we make a bit more money by doing 4 bowls and 5 plates. So the answer is going to be 4 bowls and 5 plates, and that will optimize my profit. So you'll have a chance to practice this, and obviously I'll guide you through this process because these problems are a bit tricky. And that is it. We're all done with the video.